Hello students, and welcome back to the channel. So in this video we're going to be covering pure mathematics. So this video is going to be specifically handling partial fractions as applied in advanced level. So this video is going to be suitable for students in senior 6 and in senior 5 and is presented to you by Walgembe. Now you're advised to share the video to your colleagues so that you can all benefit as a team. Now looking at partial fractions are also called algebraic fractions. So we are going to first look at how they get to be formed, and later we can reverse them back to their initial fractions. So we're going to say that earlier on algebra, we are simplifying in the first videos. We are simplifying fractions of this format. And when you're simplifying them, we told you that the first thing to do when you're having fractions is to get the LCM. After getting the LCM, then you get a simple or a one fraction, which is going to be in this format. So you're saying that here we have now reached at the stage when the reverse process is going to be applied. So if at all we are having a fraction of this format, so you're going to be looking at a specific way of how we can convert it into its initial fractions before it was a single fraction. Now we are going to first look at how fractions are going to be made and how we can reverse them later. So the reverse process is what we call partial fractions. But let's first have a review on how we can get a function that we can later partialize. So example 1 is going to be expressing 4 divided by x plus 6, then minus 2 divided by x plus 7 as a single fraction. So to do this, since it's a fraction, we say that we have to first get the LCM. And for this case, if at all we are having unknowns in the denominator, always the LCM is going to be a product of the two brackets. So let's look at the solution. So with that, we are going to first rewrite our expression as 4 divided by x plus 6, then minus 2 divided by x plus 7. Like I said, our LCM is the first thing to be got, and it's going to be the product of what you're having in the denominator. So when you do that, we are going to end up with our LCM, and then you put it here. So just like for LCM factors, we get this and then we divide it by the denominator of the first value. So if you get your LCM, which is 6, divided by this denominator x plus 6, you're going to remain with x plus 7. And then you multiply it with the numerator, which is 4. That's why we ended up with 4 into bracket x plus 7. Then minus, which is here, 2 into bracket. If you divide this by x plus 7, you're going to remain with x plus 6. Then you multiply what you remain with by the numerator, and then you get minus 2 into x plus 6. So after that, we open up our brackets. So 4 times x, you get 4x. 4 times 7, you get 28. The negative 2 times x, you're going to get negative 2x. The negative 2 times positive 6, you're going to get negative 12. So simplifying everything, 4x minus 2x, you end up with 2x. Then 28 minus 12, you're going to end up with 16. And then your LCM will still be left in the denominator. And we make a conclusion that therefore simplification of this fraction minus this fraction is going to give us a single fraction, which is going to be of this format. Now let's look at the last example under that. So here we are going to be simplifying this as a single fraction. But if you look at when you are finding LCM, we don't want a quadratic to be present in the denominator. So the first thing we do is to factorize that quadratic into its particular brackets. So if you look at this quadratic, if you put it in the calculator, you get the first value of x to be negative 1. That means that your first factor is going to be x plus 1. And then the second value to be negative 2. That means that your second factor is going to be x plus 2. And therefore, your LCM, if you look at both of these ones, we are going to have 2x, we are going to end up with this expression, 2x divided by x plus 1 into x plus 2, then plus 3 divided by x plus 1. And we said that to get the LCM, we must have all the brackets present in the denominator. But if you look at this denominator of 2x, we already having x plus 1. That means that we cannot rewrite x plus 1 in the denominator. So we shall take x plus 1, then x plus 2 as our LCM. And on that here we are going to remain with 2x, and here if you get this LCM divided by this, you are going to remain with x plus 2. That's why you are seeing that we got x plus 2 and then you multiplied it by 3 to get plus 3 into x plus 2 on this step. So after that, we open up our brackets. So if you open up the brackets, you're going to have 3 times x to give you 3x, and then plus this 2x, you're going to end up with 5x. Then 3 times 2, you're going to end up with 6. Then divided by your LCM, which you have just obtained. And then you make a conclusion that therefore the general solution for adding these two fractions is going to be the same as this. Now let's also go through this one quickly. Say we are expressing this. Now that one which does not have a denominator, we always consider it as the same bracket. So we bracket x plus 7, then plus 1 divided by x minus 4, then plus or minus 5 divided by x plus 1. So we are expressing it as a single fraction. So first we have to get the LCM. So we have to divide this by 1. So LCM is going to be a product of this bracket and that product and that bracket. So it's going to be x minus 4 into x plus 1. That's going to be our LCM. So if you get the LCM divided by 1, you're going to get the LCM, then times the upper bracket. That's why you ended up with this first expression. Then if you get your LCM divided by x minus 4, you're going to end up with x plus 1. So x plus 1 times 1, that's why you ended up with this second expression. Then you get also the LCM, you divide it by x plus 1. You're going to remain with x minus 4. Then after that, you get x minus 4 and then you multiply it by 5, which is the numerator. That's why you ended up with this third expression. So from here, it's going to be opening brackets. Now we have already looked at simplifying and opening brackets in the previous videos. So here I just simplified everything. We are going to end up with this expression in the numerator if you open up the brackets properly. Then after that, we simplify everything by collecting like terms and you're going to end up with this fraction. And after seeing that you can no longer simplify any further, then you can make your conclusion that therefore the solution for expressing this O function as a single fraction is going to be this format. So let's also look at the example that is going to involve only figures. So if at all we are given fractions of figures containing unknowns like x and you want to express them in a single fraction, what are you going to do? So here we are going to do the same simple formula. So after expressing as a fraction, you have to solve this. So we are going to use the same knowledge. So we have to convert this fraction into an improper fraction and then later we solve. So if you look at this, 3 or number 3 divided by 5 is going to be the same as 18 divided by 5. Then plus 4 over x plus 5. So after making sure that everything is in terms of a fraction which is in the form of a divided by b, we get our LCM. LCM is going to be the product between x plus 7 and 5. So after getting your LCM, you get your LCM, you divide it by 5, and then you're going to end up with x plus 7. After ending up with that result, you multiply it by the numerator, which is 18. So you end up with 18 into x plus 7, then plus 4 into 5. So opening up these brackets, you get 18x plus 126, then plus 20 divided by 5 into x plus 7. Then simplifying your numerator, 126 plus 20, you're going to get 146, then divided by your LCM. So this is the single fraction that you are looking for. So proceeding to the nth part, they told you that and solve this equation. But remember that you have already expressed these two fractions in terms of a single fraction. So what you have to do is to replace it. And if you replace it, it's going to become of that format. Now here, since we're having one fraction this side and we're also having one fraction this side, we just cross multiply. And if you cross multiply, you end up with 5 minus x into 18x plus 146 being equal to 40 into x plus 7. Now if you look here, we open up brackets. So in opening up brackets, you realize that you're going to have x squared and x. And we said that in the previous videos, if at all you're having unknowns of different degrees, when you're having a squared and you're having a linear unknown, that means that that is most likely to be a quadratic function. So what we do is that we collect like terms. Since we learned that in the previous video, I decided to skip it so that you do it as your assignment. And then you must end up with this quadratic equation. 18x squared plus 96x minus 450 is equal to 0. Now you have already looked at three methods of solving quadratic equations. So in this case I used factorization method. But before using factorization method, I first prime factorized out 6 because it was common on all figures. Then later, the remaining equation gave me these values using the factorization method. But you can also use the quadratic formula, or which you call the Bordosa formula, which is available in your logbooks. So simplifying, you're going to get the value of x to be negative 25 over 3, and also the value of the other x to be positive 3. And those were the solutions which are required. So having covered that, you first pause the video and then you take a simple assessment that is going to test your understanding of what you have just covered. You make sure that the answers that you get align with the answers I suggested for you in the questions. And for others, you make sure that you find the LCM and then you simplify as a single fraction according to the notes that you have just taken. So you pause the video and then you put the questions down. Now with that being covered, assuming that you have understood how we get single fractions from unit fractions, so now let's go to the reverse process of converting those single fractions that you have been getting back into their initial unit fractions, and that's what we call partial fractions. So there are four basic types of partial fractions, or what you can call algebraic fractions, and they can be expressed in terms of their unit fractions. So here we are going to involve the same process. The first process is first getting the LCM of the original fraction, then later substituting for any value of x, as we are going to look at it in the example. Now let's look at category 1. We say that there are 4. We are going to look at each of them one by one in this video. So type 1, you're going to look at the denominator with linear factors. Now when we say linear factors, we mean that your unknown value of x is not going to have any other power apart from 1, implying that there must not be any x value which is having a power of 2 and above. That's what we call linear. X must not be having a power which is greater than 1, or it must be x without any particular power. That's what we call linear factors, and they are going to be in the form of ax plus b, where x, its highest degree or its highest power is 1 plus a given constant. So you're saying that each linear factor, which is going to be in the form of ax plus b, in the denominator has a corresponding partial fraction of the following format, where a, b, and a are going to be constants. Now let's look at an example to elaborate that fully. So one, you are going to start by expressing 7x plus 8 divided by x plus 4 into x minus 6 into its unit fractions, or what we call partial fractions. Let's look at the solution for that. So when you're looking at it, when you're facing partial fractions, the first thing we said to do is to analyze the LCM, and you have said that the LCM is always going to be the denominator of your original function, which you are expressing in terms of partial fractions. So here, our LCM is going to be bracket of x plus 4 into x minus 6. So after analyzing your LCM, then we have to expand our fraction back into its units. If at all you're having two brackets multiplying each other in the denominator, we assume that we added two fractions and we separate the two fractions using the denominators. That's why we told you here that this expression is going to be identical. Now notice that here we are using identical sign, but we're not using equal sign, simply because we have unknowns which are present on our right hand side. So we simply say that to get the first fraction, I say that we base on the first bracket which is present in the LCM or the denominator. So it's going to be a divided by the first bracket which is present in the denominator, which is x plus 4, then plus b divided by the second bracket which is present in the LCM or which is present in the denominator of the original fraction. So here I say that you are going to multiply through by the LCM, which is going to be the denominator of the initial function of the original function, which is x plus 4 into x minus 6. So if you multiply through by that, if you multiply through by our LCM, you realize that if you multiply it through this side, the denominators are going to cross, and then you are going to remain with 7x plus 8. And if you multiply it by a, only x plus 4 is going to go with x plus 4. So you're going to remain with a into x minus 6, as you're seeing it here. So if you multiply it with b, if you get your LCM and you multiply it with b divided by x minus 6, these two brackets cross, and then you remain with b into x plus 4. So that's what you call partializing. Now here on this step, we use logic to identify which values of x can we substitute for one of the brackets to become 0. So if you want to eliminate b, we have to let x to be negative 4. I hope you are seeing that. And if you want to eliminate a, we have to let x to be 6, positive 6, because if you get 6 minus 6, this bracket becomes 0. So we aim at making either of the brackets to be 0. That's why we told you that putting x minus 6 to be equal to 0, your value of x must be equal to 6. And therefore, that means that this bracket, we have made it 0, so it's going to be a times 0 to give us 0. And this side, you're going to remain with, if at all x is equal to 6, it's going to be b into 6 plus 4, which is 10. Then you're going to end up with 10b. That's why you're seeing this expression. And if you substitute for x this side, it's going to be 7 times 6, then plus 8. So after computing everything, you're going to remain with 50 to be equal to 10b. And if you make b the subject, by dividing through by 10, you're going to end up with b being equal to 5. I hope that is clear. Also, since the other time we made the bracket of a to be 0, so this time we make the bracket of b to become 0. That's why we told you that putting the bracket of b, which is x plus 4, to be equal to 0, we make x the subject, the value of x is going to be equal to negative 4. So we substitute for negative 4. So it's going to be 7 into negative 4, then plus 8 to be equal to a into negative 4 minus 6. Remember that this is already 0. We rated it to be 0. So b times 0 gives you 0. So you're only going to have the bracket of a, which is negative 4 minus 6. So if you compare this side, you're going to end up with negative 20 to be equal to negative 10a. So if you divide through by negative 10, and this side by negative 10, you're going to end up with your value of a to be equal to 2. Then after getting these two values, or the unknowns, which is a and b, you come back and you make a conclusion. But I want you to notice that here, when you're starting up here, you realize that we use the identical sign simply because we had the values of a and b to be unknown. After getting those values, we come back and we make a conclusion, but this time round we use an equal sign simply because the values of a and b are now known. So it's going to be 2 divided by x plus 4, then plus 5 divided by x minus 6. And that's how we partialize single fractions into their respective unit fractions. Now let's look at example 3 or example 2 under partializing. We are also supposed to partialize this into its respective partial fractions. Now remember, I told you that the first thing to do when you say quadratic, we first turn a quadratic into we first factorize it completely into its respective factors, and then later we partialize. So let's first do that. Now this was a bit tricky, but the denominator, that bracket which is a quadratic, if you put it in the calculator, you're going to get two factors which are going to be x plus 3 into x minus 4. So after that, that means that this expression is going to be the same as this. I hope you have seen a difference in the denominator. So after that, we have to expand this, we have to partialize this single fraction into its respective fraction units. But to do that, we say that we give each and every bracket in the denominator a constant, and then we divide it by that bracket. So that's why you're seeing that the first value is going to be a divided by x plus 2, then plus b divided by x plus 3, then plus c divided by x minus 4. Notice that we have used the identical sign instead of the equal sign simply because we are having unknowns in our expression. Now the next thing here was supposed to be multiplying that by the LCM, because this one is going to be a little bit tricky. So the LCM is this. So let's try to make a side work here. The LCM is going to be the denominator which is present on your right hand side. So we are supposed to get this, and then we multiply it out by this expression, by this expression, by this expression, and also by this expression. So if you multiply it out by this side, you realize that each and everything goes away, and then you are going to remain with your numerator, which is 9x squared, then plus 34x, then plus 14 to be equal to, if you get this denominator and then you multiply it by a divided by x plus 2, you're going to end up with a into bracket, because x plus 2 goes away on both the LCM together with the denominator, and then you remain with a into bracket x plus 3 into x minus 4. So you keep doing that also for b, then plus b. If you multiply the LCM by this next value, the bracket of x plus 3 goes away, and then you remain with b into x plus 2 into x minus 4. And then you do the same thing to that value of x, to the value of c. So what you do here, this one you need to do some bit of self-personal study, but what you do is going to be the same thing the other side. We focus at making one of the brackets or one of the coefficients of either a or b or c to be 0. So what you're going to do after expanding them in this format I've explained to you, you're going to use these values that I gave you, and you must be getting your value of a to be equal to positive 3. You get your value of, you also substitute for x equals negative 3, and you must get your value of b to be equal to negative 1, according to what we did in example 1. Like I said, it was a computer error, and the computer tried to diminish the space as I was presenting this video. So the work got disorganized, and you're supposed to get the value of c to be equal to positive 7. Use the procedure that you have used in example 1. For any issues, you try to raise them up. So later, after getting the values of a, b, and c, we make a conclusion that therefore that single fraction is going to be equal to this, then minus this, then plus 7 divided by x plus 4. But I've told you that first expand in this format, after that start substituting. We do substitute for these values because we want to make coefficients or partialiters to be equal to 0 as we get others. I hope that is understandable. So now let's look at an assessment to guide our understanding for this. So you pause the video and then you first take down this assessment to test your understanding. I provided all the answers simply because some of you may get confused on the way. But make sure that the first example was elaborative. Use that example to solve the second example according to the instructions I've given you, and then you also try out this assessment and see whether you get these answers before you proceed to the next subtopic. Because if you don't do that, you're going to get more confused. So if you look at part C may a bit confuse you, but part C is the difference between two squares. So 25 minus x squared is the same as 5 minus x into 5 plus x. Those are going to be your two brackets. So make sure that you don't miss out there. Others are going to be simple. Remember that always the LCM is going to be your denominator, which is present on your original function. So you try them out and you make sure that you're having the same answers like the ones I provided in this tutorial. So with that, let's look at type 2, which is going to involve the denominator with an irreducible quadratic factor. Now with this we mean a quadratic factor which cannot be factorized into its respective factors. So here we are going to say that each quadratic factor which is going to be in this format in the denominator is called irreducible. It cannot be solved, or it cannot give us its respective factors. If you put it in the calculator, you're most likely to get a complex number, or the calculator will give you one value, and then on the right hand side of the calculator upwards, you see a symbol of I, which means that this quadratic is irreducible. So we are going to look at how we can solve that. So let's look at examples that can involve such fractions or such quadratic functions. So those quadratic functions, when you try to solve them, you cannot get to factors that can bring you back to this quadratic equation. So what we do simply is that we assume that if at all this quadratic function is having a degree of 2, degrees, remember that we said it's going to be the highest power which is present on the unknown in your quadratic function, according to the previous videos in this playlist. So if at all you're having your quadratic to be x squared, that means that after dividing it, that's why in the numerator I must have a degree which is lower by 1. That's why you're seeing here we made the degree in the numerator to be bx plus c. So you simply continue with the arrangement of the unknowns. But if at all you're having an irreducible quadratic function or quadratic expression, you make sure that which cannot be solved into its respective factors, then it's going to be in the form of x plus any other constant. So that's why you're seeing here plus bx then plus c, in case you're having a quadratic expression that can be solved. So here still the LCM is going to be the denominator which is present on our initial function, which was this. So you're going to multiply throughout our each and every digit which is present, both this one, also this one, and this one, by our LCM, which is x minus 6 into x squared plus 3x plus 5, to see what is going to give us. So if you have a brief review from here, you realize that if you multiply each digit by this expression, which is your denominator on the initial function, here you are going to remain only with the numerator because everything is going to cross. And if you multiply it by this, it's only x minus 6 that's going to cross. So you're going to remain with a into bracket of this. And if you multiply it by bx plus c, this bracket and this bracket is going to cross, and then you're going to remain with bracket of x minus 6. So let's look at how we can fully solve that. Now in partial fractions, now like I said, these videos are going to introduce you to the topic and give you the relevant information that you need, but I hope they are going to be further discussed by your teachers at school. So in partial fractions, we have two methods of solving them. We have using putting method, where we put the value of x to be a specific letter, and then you also have equating coefficients, whereby you see the coefficient this side is x squared, then what about the coefficients this side that are having also x squared? So you're going to be using both of the methods in solving this. So if you look at this, I've already explained this step. After multiplying it out by the LCM, you're going to end up with this expression. So from here, first we first look at a way of making one bracket to be 0. So if at all I want this bracket of x minus 6, if at all I want this bracket of x minus 6 to be equal to 0, the value of x is going to be, if I make x the subject, x is going to be equal to 6. So it means that all this function is going to be 0, and for other values that are not going to be 0, I substitute for x being equal to 6. And if I do that, if I let x to be 6, this side I'm going to have 7 into 6 squared, then plus 2 into 6, then minus 28. And simplifying my left hand side, I end up with 236. Then this side, remember that this one is already 0 since I let this bracket to be 0. So I only substitute for x equals to 6 into this expression. And if I do that, I'm going to end up with a into bracket 6 squared, then plus 3 into 6, then plus 5. Then further simplifying this, I'm going to end up with 59a to be equal to 236. So if I divide throughout by 59 to make a the subject, I also divide this side by 59. I'm going to end up with a value of a to be equal to 4. I hope you have understood that. Now the other examples, we are going to solve them by equating coefficients of x squared. So what you're going to do there is that you're going to look at your left hand side and see which value is having a coefficient of x squared. So if you look at this expression on your left hand side, you see that the coefficient of x squared on the left hand side is 7. We also spot the coefficients of x squared on our right hand side. So in this expression we're having a, because if you open up this bracket, you're going to have a x squared. So we're having a to be the coefficient of x squared. We pick it. You don't take the x squared because we are only comparing its coefficients. We don't put it in inclusive simply because we are comparing its coefficients. Now you have seen here that we added b because if you open up this bracket, you're going to have bx times x, you're going to get bx squared. That's why you're having it as also a coefficient of x squared still present on the right hand side. That's why on the left hand side we wrote 7 only, and on the right hand side we wrote a plus b, simply because both a and b have a coefficient of x squared. So after that, we have already seen that the value of a is the same as 4. So we substitute for it, and then we make b the subject by taking for this side. So it's going to be 7 minus 4 to give us the value of b being equal to positive 3. So we have so far got the value of a, we have got the value of b, now we are remaining with the value of c. So to get the value of c, we are going to be comparing terms that are independent of x or that don't have any coefficient of x. That's what we mean by comparing constant terms, terms that are independent of any unknown in our expression. So if you look at your left hand side, the value which does not have any coefficient of x is negative 28. So that's why we picked it and then we place it here. And then if you look this side, a times 5 does not have a coefficient of x, so it's going to be 5a. That's why I placed it here. And if you look here, bx times x is going to have a coefficient of x, also bx times negative 6 is going to have a coefficient of x. C times x is going to have a coefficient of x, then c times negative 6 we get negative 6c. It does not have a coefficient of x, so that's why we picked it and then we placed it here. Then after that, we have already got the value of a. We substitute for a, and then we make c the subject simply by taking 5 times 4 is going to be 20, and then we take it this side. So it's going to be negative 28 minus 20 to get you negative 48. So you're going to end up with negative 48 to be equal to negative 6c. So if you divide through by negative 6 this side, you're going to end up with your value of c to be equal to 8. I hope that is clear. Then after that, since we have found all the unknowns a, b and c, we come back and then we make a conclusion that therefore our single fraction, which was in this format, is going to be equal to 4 divided by x minus 6. Now here I used the identical sign, but it was supposed to be an equal sign, simply because I've already found my unknowns. So there's no need of using an identical sign. So it's going to be 4 since it was the same as a, divided by x minus c minus 6, then plus 3x plus 8 divided by your irreducible quadratic expression. And that's the final answer which was required. So using that knowledge, we are going to first break off a moment and then you try out this exercise. Make sure that you try out the exercises given. That's the only way you're going to understand mathematics. So you pause the video and then you first take this exercise. So for part A and part B, I gave you the solutions. For part C, part D, part E, and part F, you're going to discuss them with your colleagues together in class. So with that, let's look at another type, which is going to be category 3 before we finalize with category 4. So in category 3, we are going to have what we call repeated factors, whereby you're going to have a linear factor which is raised to a certain power. So the number of power it is raised to is going to be the number of times we have to expand that bracket. Let's look at an example under that. So one, we are going to first express the following function in terms of partial fractions. So doing that, we have to use this identical sign to be equal to a divided by, we say that we expand our partial fractions using the denominator. So it's going to be a divided by the first bracket in the denominator. Now if you look at this second bracket is raised to power 2. That means that we have to expand it 2 times in ascending terms of its powers. So 1 is going to be b divided by x minus 2 without a power, then plus c divided by x minus 2 with the power of squared. We expand up to the last power. If it was cubed, it would have been b divided by x minus 2 plus c divided by x minus 2 squared, then plus d divided by x minus 2 cubed. Depending on the power that you are having is where you stop. So after that, the working is going to remain the same, or else the LCM is going to be that on your initial function, which is this. So after getting the LCM, we multiply it out by the LCM. So multiplying it out by the LCM, on your left-hand side, you're going to remain with the same expression. If you multiply a throughout by that LCM, you will realize that you're going to remain with a, because this one and this one are going to go. So you're going to remain with a into bracket of x minus 2 squared. Then plus b into 2x plus 1 into x minus 2. Then plus c into 2x plus 1. So from here, we look at how we can make either of the brackets to be equal to 0. So let's start with how we can make both, since b and c have the same brackets, which is 2x plus 1 and also 2x plus 1, we find out making a bracket of 2x plus 1 to be equal to 0. You simply get that bracket and then you equate it to 0. And then you find that x is going to be equal to negative a half. So it's what you substitute. So that means that if at all these brackets are going to be 0, that means that b and c are going to be gone, because any number times 0 is going to be 0. So you're going to remain with, if you substitute negative half this side, you are going to end up with this expression. And since b and c are gone, we only need the expression for a. So that's why you're having this expression. So in simplify, you're going to end up with negative 25 to be equal to 25 over 4a. So if you make a the subject, you're going to end up with your value of a to be equal to negative 4. Then from there, we also find a way of making the bracket of a to be equal to 0. And how are you going to do that? So since a is having a bracket of x minus 2 and also b is having a bracket of x minus 2 and c does not have it, so we find a way of making this bracket to be equal to 0. So if you equate this bracket to 0 and then you make x the subject, you find that x is going to be equal to 2. And that's what you substitute. That's why we told you that let the value of x be equal to 2. And when it's equal to 2, you substitute on your left hand side is going to be 2 into 2 squared, then plus 29 times 2, then minus 11 to be equal to, remember that a and b are going to become 0 since they have that bracket, which we equated to 0. It's only c that is going to remain because it lacks that bracket. So you have to substitute for the value of x, which is 2. So it's going to be c into bracket of 2 times 2, then plus 1, as computed here. So computing everything, you are going to end up with 55 to be equal to 5c. And if you make c the subject, c is going to be equal to positive 11. Now we have got the values of a, we have got the values of b, and we have got the values of c. Now let's make a conclusion showing the solution. Now we are not got the value of b. With the value of b, we are going to get it by equating coefficients of x squared, just like I explained. You look on your right hand side or left hand side and recognize values that have coefficients of x squared. and then you pick them, and you do the same thing to your right hand side, and you find that it's going to be a plus 2b. Then you have already got your value of a to be equal to negative 4, so substituting it, and then if you take it this side, it's going to be 2 plus 4 to be 6, and if you divide it by 2, making b the subject, you're going to get the value of b to be equal to 3. So after that, we make a general conclusion that therefore the solution, or the general solution for partializing this function, is going to be equal to this expression. Like I said, do not use identical sign after finding the values of the unknowns. Instead, now use equal signs. So I hope you have understood category number 3. And with that, you're advised to pause the video and then you first take this assessment. Now make sure that you get the corresponding answers that I gave. If you get part A right, part B right, that means that you're most likely going to get part C and part D corrected. But remember that in part D, it's a bit tricky because this is also a quadratic formula, x squared plus 1, and it cannot be factorized. That means that in your numerator, I expect you to have ax then plus b divided by the first bracket, and then you expand this other bracket according to repeated factor theory, which you have just looked at. And for any difficulty, like I said, make sure that you engage in group discussions and then take your work for assessing and marking. Any issues, you raise them in the comment sections. Now let's look at the last category, which is going to be involving improper fractions. Now, how are you going to realize that this is going to be an improper fraction or not? So when you're going to say that an improper fraction is going to be that one in which the degree of the numerator is greater than the degree is greater or equal to the degree in the denominator. Now what do you mean here? If at all you're having, remember that the degree is the highest power which is present in a given polynomial. So if at all in the numerator you're having x power 3 after opening up the brackets, and also in the denominator you're having x power 3. Since the degrees are equal on both of these polynomials, in the numerator and the denominator, we assume that this one is going to be an improper fraction, and you are going to solve it according to the methods applicable to improper partialization. Then also, if at all you're having a higher power, for example x power 4 or x power 5, and in your denominator you're having a lower power or a lower degree to that, we're also going to consider that as an improper fraction. So you're going to solve it according to the improper fraction method of partializing. So 2, or instruction 2, we are going to simplify an improper algebraic fraction simply by dividing the polynomial with its denominator. Now we are going to look at this in details. So when a polynomial degree n is divided, we get a constant. So here, what it simply tells you is that if at all you're having a case whereby the degree in the numerator is going to be the same as the degree in the denominator, we assume that after dividing, you are going to get a constant, which is always going to start your partializing expressions. But if at all you're having a higher degree, for example, x power 4 divided by x power 3, we assume that you are going to get a linear factor, which is going to be in terms of ax then plus b, just like we are going to look at them in the examples. So instruction 2, we are going to say that when a polynomial of degree n is divided by degree m, where m is greater than n, you are going to get a linear factor. We are going to look at that. Now here we can also use long division to convert an improper fraction into a proper fraction, though for the case of this video, we only looked at the first method. Now let's look at the examples under that. So example 1, we are going to express this into partial fractions. Now how are you going to realize that it's an improper fraction or it's a proper fraction, just like we have been solving others? If you look here, in the numerator you're having x squared, and if you open up these brackets, you realize that also in the denominator you're having x squared. So since you're having polynomials of the same degree, both in the numerator and in the denominator, that means that it's going to be an improper fraction. And you have to solve it using the improper way. And you have said that if at all the degrees are the same in the numerator and the denominator, that means that after dividing, you're going to get a constant. So let's look at the way we are going to solve that. So this is just an expression in written form so that you don't forget what I say. I've already explained this. So since the degrees are the same in the numerator and the denominator, we start by A, showing that we first divided and then we got a constant. Then later, we partialize our denominator. So the partialized in this denominator is going to be B. You continue with the letters. So it's going to be B divided by the first bracket in the denominator, then plus C divided by the second bracket in the denominator. LCM is always that one, is always the denominator of your initial function, which is x plus 5 into x minus 4. So we multiply it out by our LCM on each and every digit. So you're going to end up with this on your left hand side, and you're going to end up with this on your right hand side, just like we have been explaining. So we start making these brackets to be 0. And how are you going to do that? You either make them 0 or you equate coefficients. Like I said, you pick the formula which is suitable for you. Someone may start by making this bracket 0. So if you let me try out that to find the value of C. If you have to make, since A and B have these common brackets, which is x minus 4, how can you make that bracket 0 to get the value of C? So we shall put x to be equal to negative 4. Simply by getting this bracket and then you equate it to 0. X is going to be equal to negative 4. So that means that you're going to have 5 times negative 4 minus 71 to be equal to C into negative 4 plus 5. And that's going to be your answer. So you find that your C is going to be 1. But for this case, we decided to use both methods, both letting the value of x to be something and also equating coefficients so that you don't get biased. So if at all we start by comparing coefficients of x squared, you realize that on your right hand side you only have 5. And you realize that this side we don't have any value of x squared. But on A, after opening up these brackets, you're going to have only the coefficient of A, only the coefficient of x squared to be A. That's why we told you that when you compare coefficients of x squared, you're going to get your value of A to be equal to 5. Simply because on the left hand side is 5 and on the right hand side is only going to be A. So A is going to be equal to 5 straight away. Then later we look at how we are going to eliminate this bracket. So for us to eliminate this bracket, we shall let x to be equal to negative 5. That's how we are going to make this bracket to be equal to 0. And if we do that, if you substitute for x being equal to negative 5, you are going to end up with this expression on your left hand side. And then this side, this is going to be 0, but also the one for A is going to be 0 simply because also A has that bracket. So I'm only going to remain with B to be equal to negative 5 minus 4. And if you simplify, you're going to end up with 54 to be equal to negative 9b. Now if you make b the subject by dividing through by negative 9, you're going to end up with your value of b to be equal to negative 6. Then we do the same to the value of b. So to make the bracket of b to be equal to 0, we have to let x to be equal to positive 4, because 4 minus 4 you are going to get 0. And if you do that, you're going to end up with 5 into 4 squared minus 71 on your left hand side to be equal to this on your right hand side. So you're going to end up with 9 to be equal to 9c. Dividing through by 9 is going to give you c to be equal to positive 1. After getting all the values c, b, and a, we have to come back and make a general solution for what you have worked out. So you're going to end up with your solution. You say that therefore our fraction, which is 5x squared minus 71 divided by x plus 5 into x minus 4, is going to be the same as our a, we have got it as 5, then minus 6 divided by x plus 5, then plus 1 divided by x minus 4. And that's your answer that was required. Now we are going to apply the same knowledge on these two. So if you look here, if you analyze the degrees, So before you solve any partial fractions, you have to first analyze whether it's proper or it's improper. We say that if it's improper, the degree in the numerator must be equal to the degree in the denominator, or the degree in the numerator must be greater than that in the denominator. So if you look at this function or this polynomial or the fraction, in the denominator or in the numerator we are having x power 4, so the degree is 4. But down here, if you open up these brackets, the degree is going to be 3. That means that after dividing, you're going to get a linear factor, which is going to be the same as x plus b. Then later, you partialize your denominator or your fraction according to the denominators. That's why you're seeing this expression. So you're having x plus b, then plus c divided by x plus 4, then plus dx plus e divided by x squared plus 9. Now I say that we continue. If you look at why we wrote here dx plus e is because if you look at x squared plus 9, it's a quadratic simply because the value of x is raised to power 2 and it cannot be factorized into its constituent brackets. So that's why we made the numerator to be a linear factor. Then after that, we analyze our LCM, which is always going to be the denominator, and then we multiply third by it. So multiplying third by the LCM, you're going to end up with this expression. Then there we use either equating or letting, but for this case we are going to use equating coefficients so that you can be very quick. So if you equate coefficients, you'll find the value of a to be equal to positive 3. And if you equate coefficients of x cubed, the value of b is going to be equal to negative 5. And for this time, if you let the value of x to be equal to negative 4, you find that you're going to get the value of c to be equal to positive 2. I'm not repeating this because I've over-explained it over 50 minutes. So also, if you compare coefficients of x squared, you're going to end up with the value of d to be equal to negative 1. So after getting also the value of e, we make a general solution that therefore our fraction is going to be the same as this. Now let's look at an assessment to test our understanding. So this, you pause the video and you make sure that you take down the exercise. Ensure that I always give you the solutions for the first assessment and for the second assessment to give you confidence so that you can proceed with part C and then part D. If you don't get the first assessment right and the second one right, that means that you have to review and first rewatch the video, especially in simplifying your work. Some of you make mistakes by ignoring coefficients, the sign of the coefficients. For example, if I told you having 2x minus 2, and then you're comparing constants, you tend to ignore this negative. So you need to take the signs according to the figures next to them. That's one mistake that is common under this topic. And then lastly, make sure that you like the video and then you share it with your friends so that you can all benefit as a team. So we shall meet in the next video under pure mathematics.